For you to understand our lesson better, let's just have an illustrative example. So for this problem, determine the design strength and the allowable strength of the connection shown. Use E70 electrode for the fillet welds and A572 grade 50 for the connecting members. Size of the weld is to be 8 millimeters. So what we would be solving for here would be the values of PU and PA. So that is to be the design strength and the allowable strength respectively. So when we are to speak about design strength, this is to be in LRFD. And when we are to talk about allowable strength, so this would be in ASD. So that is to be PA and PU respectively. So there, if we are to solve for those, we would be using these formulas right here. And as you can see in this setup right here, we would be having a longitudinal, which is this one right here, and transverse fillet weld. So it would be this one right here. So meaning we would be using both of these formulas right here. But for us to solve for these ones right here, we would be using this formula right here. So for FNW, so FNW, according once again to this table right here, FNW is equal to 60% of the nominal strength of the electrode. And the nominal strength of the electrode is dependent upon this label right here. So once again, this is to be 0.60 FEXX. And our FEXX is equal to, since we are to use E70 electrodes, this is to be 70 kips per square inch. So if we are to convert this into megapascal, so looking at the calculator to your left, we would be multiplying our conversion factor of 6.895. From that, our answer would be 482.65. And for this lesson's sake, I would just be rounding it to the nearest whole number. So this is to be 483 megapascals. So substituting known values, our answer here would be, so 0.60 times 483, and this is to be, so 483 times 0.6, that is 289.8. So 289.8 megapascals. So I would then be deleting this. So that is for our FNW. So we already have our FNW here. So what is to be our AWE? So our AWE would be dependent on these lengths right here. So if we are to solve for the longitudinal first, so let's solve it for it here first. So RNWL, that is to be FNW times AWE. But we already have the value of our FNW, which is 289.8 megapascals times the critical area of our welded connection. So if we are to solve for the longitudinal welds, which is this ones right here, that is to be, so I would just be changing the color, 200 mm. So that is the length times the throat or the critical plane. So once again, this area right here is to be the area of the failure plane. So it would be this one right here. Or if you would be considering this ones again, it would be this area right here. So once again, this has an angle of 45 degrees, and for us to get the length of the throat, so the throat is equal to cosine 45 times A, or A cosine 45. And cosine 45, if you would be putting this to your calculator, it is equal to 0.707. So to prove it, cosine 45, that is to be 0.707. So 0.707A. So that is for the throat. So we would be multiplying this by 0.707A. And our A right now is to be 8 mm. So times 8 mm. But take note, guys, that we would be having two longitudinal welds. So we would be multiplying this by 2. So from that itself, our answer here for the RNWL, that is to be equal to So 289.8 times 200 times 0.707 times 8 times 2, that is to be equal to 6555643 newtons. So if I am to divide this by 1000, we would be arriving at an answer in kilonewtons. So divided by 1000, that is to be 655.64 kilonewtons. So 655.643, 644 kilonewton. So that is for the longitudinal welds. How about for the transverse weld? So I would just be copying this to our next slide. So once again, it is same as with this. So for our RNWT, so this is to be the transverse strength of the welds. This is to be, so similarly, F NW times AWE. So this is to be equal to, once again, our strength is to be 289.8. So 289.8 megapascals times the area of the weld. And the area of the weld is to be this area right here. So 250 mm times, once again, our throat. And our throat is to be 0.707 times A. And our A once again is to be 8 mm. So 8 mm. So getting the answer of our RNWT, this is equal to 409,777.2. And once again, if we are to divide this by 1000 to arrive at an answer in kilonewtons, so divided by 1000, that is equal to 409.78. So 409.78 kilonewtons. So this is to be your longitudinal strength, and this is to be your transverse strength. And for us to get the value of PU and PA, we must solve for the value of PN or RN first. So for our total RN. And if we would be having a combination of both longitudinal and transverse fillet welds, we would be using these equations right here. So if we would be adding this, so by the way, I would just be copying this one right here to the next slide. So for our Rn, using this equation right here, so this is to be equal to RNWL plus RNWT. So adding both of these values right here would give us an answer of, so plus 655.644. So equal sign, our answer here is to be equal to 1065. So 1065.42 kilonewtons. Okay, so that is for this formula right here. And for this formula right here, which is Rn is equal to 0.85 RNWL plus 1.5 RNWT, that is to be equal to, so in our calculator, so that is to be 0.85 times 655.644 plus 1.5 times 409.78. So this is to be equal to 1171.9674. So 1171.9674 kilonewtons. So which one of these would govern? So according to AISC, the total nominal strength of a connection with side and traverse welds is to equal the larger of the values. So whichever is larger in these two. So in this case, it would be this one right here, which is 1171.9674. So this would be our governing Rn. So that is to be our nominal strength. So copying this to the next slide. So for us to get the design strength, so in LRFD, so PU is equal to phi PN or phi RN So this is to be equal to phi, and by the way, our phi is equal to 0.75 when we are to analyze shear in welding. So Pu is equal to 0.75 times Pn of 1171.9674 kilonewtons. So multiplying those values would give us an answer of 878.98 kilonewtons. So this is to be for the value of your Pu. And as for our Pa in ASD, Pa is equal to Pn over omega. And our omega here is equal to 2.00. So from that, our Pa is equal to 1171.9674 divided by 2. So considering that, 1171.9674 divided by 2 is equal to 585.98. So Pa 585.98 kilonewtons. So this would be your design strength and allowable strength respectively for the given connection.